You download a file and your antivirus flags it as suspicious. Or maybe it's from an unknown source and you're not sure if it's safe. Running it could infect your computer, but how do you find out what it actually does without taking that risk? Today, I'll show you the techniques that security experts use to safely analyze suspicious files. First, we create a digital fingerprint of the file using something called hashing. Think of it like a DNA testing. Every file has a unique signature. We can check this signature against databases of known malware without ever opening the actual file. But here's the thing, malware authors know about this. So they modify their files slightly to change the fingerprint. Every program has an internal structure we can examine. Here's what separates the pros from the people just running VirusTotal. Files are divided into sections: header info, executable code, program data, and resources. We use something called heuristic analysis, basically pattern recognition based on how random each section looks. Normal sections have patterns, but if something looks too random, it's suspicious, like finding gibberish in a normal book. High randomness may just be compression, or it could mean something's hidden. Pattern recognition helps flag areas worth investigating. But this is just one piece of the puzzle. Real insight comes from combining multiple techniques to see the full picture. Beyond basic file structure, we can extract readable strings hidden inside a binary. Even encrypted malware needs some readable text to function. Here we found a Python-based executable with some interesting artifacts. Both of these artifacts are PyInstaller signatures. This executable was built from Python scripts. We also see file operation logs. This could be normal install routines or error handling. Failed operations alone aren't always suspicious. But here's what's suspicious. The file claims to be a server's control manager tool, but the string's tell a different story. The highlighted pattern, that's a dynamic file name template, suggesting it's generating executables on the fly. Legitimate tools rarely do this. It also calls APIs by ordinal numbers instead of names, a classic evasion trick to avoid detection and confuse analysts. And then there's get process address with load library. That's textbook setup for process injection. Now, at first glance, none of these seem alarming, but when you connect the dots, the bigger picture becomes obvious. We've got a hash match to known malware, high entropy packet sections, dynamic code generation patterns, and a full set of injection and evasion techniques. What really stands out is the deception. It poses as a system tool, but underneath, it's a Python based executable with injection code and hidden API calls. That's not something you see in legitimate tools. This is a Trojan dropper, disguised, evasive, and fully capable of injecting malicious code and deploying further payloads. And we uncovered it without ever running the file. That's the power of static analysis, identifying threats before they get a chance to run. You don't need to be a cybersecurity pro to start. Static analysis can be safe, simple, and free if you use the right tools. Tools like VirusTotal, PEBear, and EXE help you scan files without running them. Even Ghidra, used by the NSA, is free. Here's the basic workflow. Check the hash, look inside, analyze strings. When something feels off, delete it. Every expert started here. With the right tools, you can spot threats before they do damage and protect yourself better. If this helped you, don't forget to subscribe. I'll be covering deeper analysis, real world malware, and ways to defend yourself. All the tools are linked below. Stay curious, stay sharp. I'll see you in the next one.